Welcome to the deep dive. Today, we're tackling something incredibly relevant. Whether you're prepping for a presentation with numbers, trying to understand why some people just, ace math and others struggle, or you're simply fascinated by the human mind.
Yeah,
It's the powerful connection between how students feel about themselves, the social stuff around them, and their actual success in mathematics. And for this deep dive, we've got access to a really comprehensive piece of work, an analysis that pulls together findings from a massive 143 different research studies.
exactly. And understanding what helps or hinders someone's journey with math, well, it isn't just for teachers or students, right?
Right.
It can give you valuable perspective if you're facing, say, a data-heavy project at work, or if you're a parent trying to support your child's learning, or even if you're just curious about the science of how we learn and develop skills.
Definitely.
Our goal today is basically to sift through all this research and bring you the key insights in a way that's clear, avoids all the complicated jargon, and hopefully gives you some real aha moments.
Absolutely. And the foundation of our discussion is this really significant study from 1997 called Attitude Towards Self, Social Factors, and Achievement in Mathematics, a meta-analytic review by Shin Ma and Nand Kishore. Now, a meta-analysis, it might sound a bit intimidating, maybe,
Huh?
but it's actually a super efficient way to understand a big topic. Think of it like this. Instead of just reading one person's opinion, you're getting a summary of what hundreds of different researchers have found. Mock and Kishore essentially looked at all these individual studies to find the bigger, more reliable patterns.
Yeah, and what's so valuable about that approach is that by bringing together all that information, they could see beyond the quirks or, limitations of any single study.
Right.
Maybe one study had a small group of participants, or another used a slightly different way of measuring things. The meta-analysis helps us see the forest for the trees, revealing broader trends that are more likely to be true across different situations.
Like,
So our mission in this deep dive is to extract the most important of these trends for you, specifically looking at how a student's belief in their own math abilities, the support they feel from their family, and those persistent ideas about whether math is more for boys actually connect with how well they do in math. So, shall we get into it?
definitely. Let's start by looking at the main connections they discovered. The first thing they focused on was self-concept about mathematics. In simple terms, this is about how positively or negatively a student thinks about their own math skills.
Uh-huh.
Like, do they feel they get math? Are they confident tackling problems? Or do they tend to feel anxious and think, oh, I'm just not a math person? What did a massive collection of studies tell us about this?
Well, what's really interesting is that the meta-analysis found a clear and positive link between a student's self-concept in math and how well they actually perform. When they combined the results from all those studies, they came up with this figure called a weighted mean effect size of 0.23.
Okay, 0.23.
Now, that might sound a bit abstract, but think of it this way. It suggests that, on average, students who have a more positive view of their math abilities tend to achieve higher results in math. It's not like a huge night and day effect, but it's a consistent trend that shows up across a lot of different research. So believing in yourself in math genuinely seems to make a difference.
Okay, that makes a lot of sense intuitively, right? If you think you can do it, you're probably more motivated to try, maybe more resilient when things get tough.
Exactly.
The next piece of the puzzle they examined was the perception of family support. What exactly does that involve in the context of learning math?
So this refers to how students feel about their parents' attitudes towards math, the help and encouragement they receive from their families when it comes to their math learning, and also the expectations their parents have for them in this area.
Ah,
It's about a student feeling like their family values math, believes in their ability to learn it, and is basically there to support them along the way. And similar to self-concept, the meta-analysis found a significant positive relationship here with a weighted mean effect size of 0.14.
0.14, so smaller than self-concept, but still significant.
Still significant, yeah. It shows that it's not just about your own internal view,
Yeah.
but also that external environment feeling supported by your family plays a noticeable role.
Interesting. Now, the third factor they looked at was the perception of mathematics as a male domain. This sounds like it taps into some pretty deep-seated societal beliefs. Can you explain what this measures?
Absolutely. This concept explores the extent to which students believe that mathematics is a subject that is inherently more suited for males than females.
Mhm.
It's about whether they've absorbed that stereotype that math is for boys.
Right.
And this is where things get really fascinating, because the study uncovered a significant negative relationship. The weighted mean effect size was Grado 0.18.
Negative 0.18. Okay.
What this tells us is that students who hold this perception, who think math is more of a male thing, tend to have lower achievement in math. It suggests that these kinds of societal stereotypes can actually create a real barrier to performance.
Wow. That's a really powerful finding. It just highlights how these wider social narratives can trickle down and impact an individual's learning and performance.
Definitely.
Now, when I looked at the outline, one thing that really stood out was the question of gender differences. Given these long-standing stereotypes about who's good at math, did the study find that these relationships we've been talking about, self-concept, family support, the male domain perception, and achievement, were significantly different for male and female students?
Well, surprisingly, the meta-analysis revealed that none of these three relationships showed significant differences between male and female
Oh,
students.
not at all.
None that were statistically significant across this large data set. That's a key point to take away. Whether we're looking at how your belief in your math abilities relates to your performance, how family support impacts achievement, or how the male domain belief affects results, these factors seem to operate in a largely similar way for both boys and girls, according to this broad analysis.
Huh.
So while the stereotypes themselves might exist, their impact on these relationships with achievement doesn't seem to be fundamentally different based on gender here.
That's really insightful and maybe challenges some common assumptions we might hold. Okay, let's shift focus now to how these relationships might evolve as students progress through school. What did the meta-analysis uncover regarding trends across different grade levels? Let's start with a connection between self-concept and achievement.
Right. What's particularly interesting here is that the link between how students feel about their math abilities and how well they do, well, it isn't the same across all ages. In fact, this relationship was strongest during junior high. They define that as grades 7 through 9, with that effect size jumping up to 0.37.
0.37, wow, that's quite a bit higher than the overall average.
Yeah, it suggests that for students in those middle school years, their confidence and belief in their math skills seem to be particularly closely tied to their actual performance. This link was noticeably stronger than in elementary school, grades 1 to 6, where the effect sizes were around 0.24, 0.25, and also significantly stronger than in senior high, grades 10, 12, where it dropped down to 0.12.
Down to 0.12, that's a big drop.
It is. So those junior high years appear to be a really important time for the interplay between your math self-belief and your math success.
That's a pretty significant shift across those school years. Why do you think that relationship might be so much more pronounced in junior high compared to the later high school years? Like, what's going on during that middle school period?
That's a really good question. It could be that as students get older, their self-perceptions in math become maybe more ingrained, less influenced by immediate successes or setbacks.
Okay.
Also, as the math curriculum gets more advanced in high school, new challenges might emerge that affect achievement regardless of how confident a student felt earlier on.
Right, like calculus versus basic algebra.
Exactly. And it's also possible that social comparisons with peers become more intense in later adolescence,
Yeah.
impacting self-concept in ways that don't directly translate to changes in achievement. So a student might still feel okay about math, but maybe their relative standing in a more competitive environment doesn't boost their achievement in the same way strong early confidence might have.
Those are interesting points. Now, what about the relationship between family support and math achievement across these different grade levels? Did that pattern look similar?
Not exactly the same, no. The study found that the positive link between perceived family support and doing well in math actually got stronger as students moved from elementary school, effect size 0.11, into junior high, 0.16.
Okay, so it increases initially.
Right. It seems like feeling supported by your family becomes increasingly important for math performance during those middle school years. However, similar to what we saw with self-concept, this relationship then weakened in senior high, dropping to an effect size of just 0.06.
0.06, okay. So both self-concept and family support seem less strongly linked to achievement in those later high school years.
That's the trend suggested here, yeah.
That makes sense too, I suppose. As students get older, become more independent, the direct influence of family support on their day-to-day academics might naturally shift as, peer influence and their own autonomy take on bigger roles.
Precisely.
Now, finally, how did the perception of math as a male domain play out across the different grade levels in this analysis?
Interestingly, this particular perception wasn't really looked at much in the elementary school studies included in this meta-analysis.
Oh.
However, when they examined the secondary school years, the negative link between thinking math is more for males and lower math achievement was more noticeable in junior high, with that effect size of -0.18, compared to senior high, where it was weaker at meta 0.09.
So again, stronger in junior high?
Yes, it seems like this stereotype might have a stronger hold, or perhaps a more negative impact, during those junior high years as well.
It's quite striking how all three of these relationships, self-concept, family support, and the male domain perception, seem to lose some of their strength as students move from junior high to senior high. That seems like a pretty significant overall trend.
Absolutely. It suggests that the key factors influencing math achievement might evolve as students progress through their secondary education. Perhaps other things like a student's intrinsic motivation or maybe the perceived relevance of mathematics to their future career goals become more influential in those later years of high school.
That's a good point. Let's move on to another really interesting aspect they explored: whether a student's ethnicity might play a role in these connections. Did the study find any differences in these relationships across different ethnic groups? Let's focus on the link between self-concept and achievement first.
Yes, this is an area where some important differences emerged. The meta-analysis showed that the positive relationship between believing in your math abilities and actually doing well in math was notably stronger for white students, with an effect size of 0.44,
0.44, oh.
and Asian students at 0.39, compared to black students where the effect size was 0.09.
Only 0.09.
Yeah, and students from other ethnic backgrounds at 0.0. This suggests that for white and Asian students in this analysis, a positive view of their math abilities seems to be much more closely linked to their actual performance than it is for black students and those from other ethnic groups.
That's a really significant difference. Do the researchers offer any potential ideas about why we might see this kind of variation across different ethnic groups?
They do suggest a few possibilities, and they're important to consider carefully. One idea they raise is the potential impact of societal stereotypes.
Okay.
They propose that for minority students who may be facing negative stereotypes about their math abilities, the link between their own self-belief and their achievement might be weakened because these external negative beliefs could be playing a more dominant role. It's a complex issue, you know? And this finding really highlights the need for more research to understand these dynamics better.
It certainly does. Now, what about the relationship between feeling supported by your family in math and your actual math achievement across different ethnicities? Was that as varied as the self-concept link?
Interestingly, no.
Hmm.
The study found that the relationship between perceiving strong family support and higher math achievement was relatively consistent across the different ethnic backgrounds included in the analysis.
Oh, that's good.
Yeah, while there was one instance of a slightly smaller effect size reported for students from other ethnic backgrounds, the researchers themselves noted that this was based on only one study and cautioned against drawing strong conclusions from it. So overall, the feeling of support from family in mathematics seemed to be a consistent positive factor for achievement across different ethnic groups in this large collection of studies.
That's an encouraging finding, actually. It points to a potentially universal way that families can positively influence a child's math learning, regardless of their background.
Agreed.
The meta-analysis also delved into some of the, let's say, methodological details of how the original research studies were conducted, specifically looking at whether the way they selected participants, their sampling methods, might have influenced the results. What did they find there?
Right, this gets a little bit into the technical side of research, but it has important implications for how we interpret these findings. When it came to the relationship between a student's self-belief in math and their performance, studies that used random sampling methods.
Where everyone has an equal chance of being picked.
Exactly. Those studies actually showed a significantly stronger positive relationship compared to studies that didn't use random sampling. This suggests that the way you choose who participates in a study can affect how strong this connection appears to be.
That makes sense. Random sampling generally gives you a more representative picture, potentially leading to more reliable conclusions. But what about the other factors, like family support and the belief that math is a male domain? Did sampling methods affect those relationships in the same way?
This is where it gets a bit counterintuitive. Surprisingly, for both the perception of family support and the perception of mathematics as a male domain in relation to achievement, studies that didn't use random sampling actually reported a stronger relationship.
Stronger without random sampling. Huh. Why would that be?
Well, the researchers suggest a few possibilities. It could be that the non-random samples in those studies happen to be more specific or localized groups, where these social factors just had a more pronounced impact.
Oh.
It also raises interesting questions about potential biases in studies that don't use random sampling. Perhaps they were focusing on groups where these effects were already suspected to be strong,
That's a fascinating point. So The way the original research was designed seems to have had a real impact on the findings, which is definitely something to keep in mind. The meta-analysis also considered the size of the original studies, how many students participated. How did the number of students in a study relate to the strength of these connections?
Focusing again on the link between self-concept and math achievement, the analysis found that this positive relationship tended to be fairly consistent in studies, with smaller numbers of students, say, less than 300, with those effect sizes averaging around 0.31.
Okay.
However, this relationship appeared to be somewhat weaker in studies that had larger samples, more than 300 students, dropping down to an average effect size of 0.22.
Why might we see a weaker relationship in those larger studies? It almost feels counterintuitive. You'd think more data would give you a clearer picture, maybe?
Yeah, it does seem that way. One possibility is that larger, more diverse groups of students might just have a wider range of other factors influencing their math achievement, things we haven't even talked about.
Right.
And that could make the specific impact of self-concept appear less pronounced when you're looking at the group as a whole. Also, as we just discussed, many of the very large-scale studies might not have used random sampling, which could introduce other complexities that affect the observed relationships.
Right. Those methodological details seem to weave their way through a lot of these findings. Now, what about family support and the male domain perception? Were their relationships with achievement also affected by the size of the studies?
For both of those factors, the meta-analysis found that their relationships with math achievement remained relatively consistent, regardless of whether the original studies had smaller or larger numbers of participants.
Interesting. So less variation there based on sample size.
Exactly. It suggests that the impact of feeling supported by family and the belief about math being a male domain might be more stable across different scales of research compared to self-concept.
That's interesting. It seems like a student's own belief in their math abilities might have a more nuanced relationship with the study characteristics compared to these social and cultural influences. The meta-analysis also looked at whether these relationships had changed over time, examining studies conducted in different decades. What did they find on that front?
When it came to the link between self-concept and math achievement, the study observed a trend of increasing strength over the period they examined. The effect size rose from an average of 0.24 in studies done between 1966 and 1975 to a notable 0.41 in those from 1986 to 1993,
Quite a jump.
although there was a slight dip in the early 1980s. The researchers suggest that this increase might be partly due to improvements in how researchers were actually measuring self-concept in the later studies.
Ah, better tools.
Potentially, yeah, maybe leading to a more accurate understanding of its connection with achievement.
That's a good point. As our understanding and research methods get more refined, we can often get a clearer picture of these complex relationships. What about family support and the male domain perception? Did their influence on achievement also show significant shifts over time in this analysis?
According to this meta-analysis, the relationships between perceived family support and math achievement, as well as a perception of math as a male domain in math achievement, remained relatively stable across the period studied,
Which was roughly.
roughly from the 1970s to the early 1990s for this data. So it suggests that the general impact of those factors might have been less subject to changes over time compared to that self-concept achievement link.
Okay. One final point from our outline that I wanted to touch on was the idea of interaction effects. Did the study explore whether the interplay between factors like gender, grade level, and ethnicity had a combined effect on these relationships?
They did look at that. And the analysis actually found no statistically significant interaction effects between gender, grade, and ethnicity on any of the three relationships they examined.
No interactions. That's
Yeah.
interesting.
It is quite interesting, yeah, because it suggests that the individual effects of these factors, for example, how self-concept relates to achievement or how important family support is, largely operate independently of each other, at least based on this large pool of studies. So the impact of your math self-belief on your performance doesn't seem to be significantly different for boys versus girls, or across different grade levels or ethnic backgrounds when considered together.
Right. It simplifies things in some ways, suggesting these factors have their own distinct influences rather than being heavily dependent on combinations of these demographic variables. Now, the researchers also briefly compared their findings with earlier research in this area. What were the main points of comparison they noted?
They mentioned that their overall findings generally align with what previous meta-analyses had shown about the broader connection between, how you feel about yourself academically and how well you tend to do.
Oh,
However, they did point out some interesting nuances, particularly in the trends they observed across different grade levels. For instance, earlier research might have suggested a continuous increase in the self-concept achievement link as students progress through school, whereas this study highlighted that peak during the junior high years.
Right, the 0.37 effect size.
Exactly. And this really emphasizes the value of looking specifically at self-concept in mathematics rather than just general academic self-concept.
Absolutely. It shows that focusing on a specific subject area can reveal more detailed and perhaps more actionable patterns. Finally, let's touch on some of the wider implications and additional thoughts that the researchers offered based on their comprehensive analysis.
Sure. One key implication they emphasized is that your belief in your math abilities isn't just some general feeling of confidence. It's a specific belief about your skills in math. And this specific self-concept has a particularly strong connection to how you perform in math.
Makes sense.
They also suggested that our overall math self-concept is likely built up from our perceptions of how well we do in different areas of math, like maybe problem solving or understanding concepts or computation. So success in those specific areas can feed into a stronger overall belief in our math abilities.
They also briefly mentioned the internal-external, or IE model. Can you give us a quick explanation of what that idea suggests about how we form our self-concept?
Absolutely. The IE model is basically a way of understanding how we develop our academic self-esteem by comparing our abilities in different school subjects. So, for example, you might feel really good at math, not just because you get good grades in math, but also when you compare your math skills to how you feel you perform in, say, English or history.
Ah, the comparison effect.
Right. If you feel significantly better at math compared to these other subjects, that can boost your self-concept, specifically in math. So it's not just about your absolute performance in one area, but also how you see yourself relative to your abilities in other areas.
That makes a lot of sense. It's all about that internal comparison we're constantly making in our own minds. The researchers also touched again on why these relationships might seem to weaken in the later high school years and why the link between self-concept and achievement might be less strong for some ethnic groups.
Yeah, they proposed that the decline in those later high school years could be due to a few things, like perhaps stronger societal stereotypes becoming internalized as students get older, or maybe students' beliefs about their own abilities just become more fixed and less open to change by them.
Okay.
And regarding the ethnic differences in the self-concept achievement link, they revisit that idea that minority students might be internalizing negative stereotypes about their math abilities, which could then weaken the connection between their own belief in themselves and their actual performance.
Right.
They also brought up a really thought-provoking point from other research that sometimes students who drop out of school can actually have higher self-esteem than students who graduate but don't go on to college.
Really. Higher self-esteem.
Yeah, suggesting a really complex relationship between how we see ourselves and the academic paths we ultimately take. It's not always straightforward.
That's a fascinating and somewhat unexpected point that really underscores the complexity of all these factors. So as we bring this deep dive to a close, can we maybe summarize the key insights that we've gained from this comprehensive meta-analysis?
Sure. In essence, this large-scale analysis clearly demonstrates that how students perceive their own math abilities, their self-concept, along with the support they feel from their families regarding math, and their beliefs about whether math is more of a male subject, all have really important connections with how well they achieve in mathematics.
Okay.
However, the strength of these connections isn't constant across the board. It changes depending on the grade level of the students, particularly peaking in junior high and then declining. And in the case of self-concept, it also varies across different ethnic backgrounds.
Right, with stronger links for white and Asian students in this data.
Exactly. But interestingly, gender itself didn't appear to be a significant factor in differentiating these relationships in this particular study.
That's a really helpful summary, bringing together a lot of complex information, and it certainly gives us a lot to consider. So for you, our listener, here's a final thought to really chew on. Given these insights into the power of self-belief, the importance of family support, and the negative impact of gender stereotypes in math, how could educational approaches be specifically designed to foster and strengthen positive math self-concepts in all students? How can we ensure consistent and effective family support for math learning across all grade levels and diverse backgrounds? And, maybe most importantly, what are the most effective ways to actively challenge and dismantle those outdated and harmful gender stereotypes that unfortunately still seem to persist in the world of mathematics? Think about what these findings might mean for your own learning journey, or perhaps for how we can better support the education and development of those around
Well,
us.
yeah, and if this deep dive has sparked your curiosity, you might find it valuable to explore further into the different models of self-concept, like that internal-external framework we discussed, or maybe look into more recent research to see how these relationships might have evolved or been further clarified since this comprehensive analysis back in 1997. There's always more to learn and understand, isn't there?